Still in Unit 3, still talking about everything that has to do with relations and functions. So this next page in your journal is talking about function notation. Here's what I want you to understand about function notation. It is just a fancy way to write exactly what we've been doing. That's it. It is just fancy. It is one of those things that in math, remember that we talked about in math, some of the things this year were, if you have more than one solution, we put it in those brackets, and that's called our solution set. So it's very specific to Algebra 2 and Pre-Cal and Calculus as you go along. And this is the same thing. This is training so that when you get to the upper level math, you have just another way to write it. So algebra is all about equations. Y equals 4x minus 1. We've seen that before. Function notation, I don't want you to overthink it. It is just a fancy way to write something. And here's how we do it. We already know that x is an input and y is an output, right? Watch the only thing I'm changing. F of x equals 4x minus 1. Notice, x is still my input. X is still my input. I have not changed the machine part, right? When an input goes in, the machine does its work. Here's the machine work, and here's the machine work. That stays the same. So x is still my input. The only thing that has changed is my output. Here it's read y, but here it's called f of x. So we read it in a certain way. This is read as f of x. And a lot of times students ask, well, why do we do that? Because when we get to upper level math, we're going to have maybe 15 graphs on one coordinate plane, and we have to be able to read them. So what they do is they change this. Sometimes it's f of x, sometimes it's g of x, h of x. It just depends on what function we're talking about. So over here, x and y, those are standard, right? You got your x-axis, and you got your x-axis and your y-axis. But here I can be more specific because I may have more than one function. I don't want to limit it to y. I want to talk about my f function. I want to talk about my g, my h, all these other functions. So that's why we talk about function notation, because we're talking about more than one. So what you can look here is that f of x is the output, which is the same that it's been. I'm just changing it. And x is the input. That hasn't changed. X will always be my input. Y will always be my output. But in this case, I'm talking about my f function. So f of x is my output. Okay? So function notation is especially useful for finding a value in the range that corresponds to a certain domain value. So what that means is, remember, x is my domain, y is my range. So if I want to evaluate, this is still my x value, right? That's still x. That's still, it's read f of x equals 4x minus 1. So function notation comes into part because it's asking, okay, find my output when my input is -7. So it's still saying, find your output when x is -7. So when x is -7, I get -28 minus 1. And so now, when x is -7, my output is -29. So look at that. Here's how my answer is written. My answer is written as f of -7. So my f function, when my x value is -7, my output will be -29. So when x is -7 in this certain function, my output is -29. So that's what it looks like in an ordered pair. So it's very specific. So that's when it says it's especially useful for finding a value in the range that corresponds to a certain domain, it's telling me my certain domain is -7. What's my range? -29. All right. So let's take a look and see what this question is really talking about. This question is saying, okay, we're here on my f function. What I want you to find is when my input of this function is 5, what is my output? So I can say, when my input is 5, f of 5. My output is going to be 5 plus 7, which is 12. So that's how my answer is written. But what I want you to understand is that when my input is 5, my output is 12. So I can write it a couple of different ways. Okay, let's look at number 3. Okay, so now what this is saying, it's saying, well, here's my function h. I'm talking about a new function h. And when h is 9, when my input is 9, what's my output? Well, if I plug in 9, I get 2/3 times 9 is 6. 6 minus 1 is 5. And so when my input of h function is 9, my output is 5. That's how my answer is written. I can write it as an ordered pair. So when it's 9, my output is 5. Either way is acceptable for me. Okay? All right. So now, if you look at number 5, it's saying, okay, here I am talking about my f function. So when my input of my f function is 5, what's my output going to be? So now I've got to evaluate. Well, negative 5 squared plus 6 times 5 minus 4. Remember, we've evaluated all year long. So when x is 5, so I plug in a 5 here and a 5 here. Nothing changes. And I get 5 squared. Remember, it's 5 squared, not negative 5 squared. 5 squared is 25. Bring down the negatives to negative 25 plus 30 minus 4. So here I get 5 minus 4 is 1. So when my input of my f function is 5, my output is 1. That's how I write my answer, or I can write it as an ordered pair. When my input is 5, my output is 1. Either one of those is acceptable. All right, let's look at number 7. So now it's saying, okay, when my input is negative 5, what is my output? So when my input is negative 5, notice everything that's x changes to a negative 5. Everything else remains the same. Plus 4 times negative 5 minus 9. So now I get negative 5 squared is 25. 2 times 25 is 50. 4 times negative 5 is negative 20 minus 9. And so then I get 30 minus 9 is 21. So when my input is negative 5, my output is 21. Or when my input is negative 5, my output is 21. Okay, so hopefully that's making sense. Now, let's jump to the next page. Look at that. When my f function input is c plus 7. So my input now is not just one number, it's this c plus 7. So that's what the question's going to ask. Well, when my input is c plus 7, what is my output going to be? So in place of my input, which is x, I've got to put, my x value now stands for c plus 7. That's my input, plus 11, finish it out. And so now I have to distribute. I get 4c plus 28 plus 11, and I'm just going to simplify this expression, and I get 4c plus 39. I can't simplify anymore. That's as simple as I can get it. So how do I write my answer? Well, same way. When my input is c plus 7, my output is 4c plus 39. Or when my input is c plus 7, my output is 4c plus 39. The concept, the basic information remains the same. I just evaluate it a little bit differently. Let's do number 10 just to get some more practice. Okay? So, when my input now is 2k minus 5, what is my output? So, everything remains the same. Negative 9 minus, in place of x, I got to plug in all of this. So, I'm going to put parentheses around it because it's a binomial. So I get 2k minus 5. And now I simplify. Negative 9, distribute my negative, negative k plus 5. I simplify, and I get negative 2k minus 4. So when my input is h is 2k minus 5, my output is negative 2k minus 4. If I want to write it as an ordered pair, when my input is 2k minus 5, my output is negative 2k minus 4. So still input, still output. Okay? All right. Now, it says, for questions 11 through 16, so we'll do 11, 13, and 15, use the functions to the left. Okay, so now See what I mean? We've got more than one function that we're working with here. We have an f, g, and h function. So number 11 first calls attention to my f function. So now it's saying evaluate this function when x is 4. So I'm going to do that. I'm going to do exactly what it says. I'm going to evaluate where my input is 4. So in place of my, here, I get 8 minus 3 times 4. Does everybody see that? Here's my f function. So in place of x, I'm putting 4. So 8 minus 3 times 4. And then I got to tack on this information, plus 9. I'm just finishing out the question. And if you want to evaluate first, like we were doing up above, don't forget to tack on that 9 later. So I'll show you 2 ways to do it. Here's the first one. 8 minus 12 plus 9. So I get 17 minus 12, and I get 5 as my answer here. Okay? That's just all taken together. But if you want to evaluate it like we have been doing, where f is, so when my input is 4 for my function, I get 8 minus 3 times 4. That's the way we're doing it up above. And so when you get that, you get 8 minus 12, and 8 minus 12 is negative 4. Okay? So now I have evaluated my function at 4, but the question is saying f of 4 plus 9. So I can't forget to tack on that plus 9, and I still get positive 5 as my answer here. Okay, so you're evaluating a couple different things at the same time. Let's look at number 13. So now it's saying you're going to evaluate my g function at 4. You're going to get an answer. You're going to evaluate my g function at negative 1. You're going to get an answer. And then we're going to add them together. So let's do that. So if you have, not f, we're looking at g. So we have g of 4 is going to be, here's my g function that it's talking about, and it's saying x squared plus 2x. So in place of x, I'm going to put 4 squared plus 2 times 4. Okay? And then I get 16 plus 8. And 16 plus 8 is 24, right? Is that right? Bar 4, no, it's not. Yes, it is. Brain fart, sorry. Yes, it's 24. So, g of 4 is 24. So, my answer here is 24. And now, when g is negative 1, I have negative 1 squared plus 2 times negative 1. And I get 1 minus 2 is negative 1. So now I have evaluated g of negative 1 and g of 4. But what is the question asking me to do? It's saying add them together. So 24 minus 1 is equal to 23. So my answer for number 13 is 23. Okay? All right. How much time? We're 13 minutes on the video. Let's do another one over here. And then we'll go to, let's just do a couple more practice problems. Okay, let me expand that to 100 so I can see. So now it's talking about an h function. So my h function is negative 5 halves x minus 1. And then my f function is 8 minus 3x. So I'm going to expand this again, but now I kind of know what I'm talking about over here on number let's do 14. So, it's saying evaluate when my h function is 2, so I'm going to go ahead and do that. When h is 2, I get negative 5 halves 2 minus 1, okay? And then I get negative 5 minus 1 is negative 6. So when h is 2, my output is negative 6, okay? Now I want to evaluate when f is negative 9. So notice, I'm doing this, and now I'm going to do this. And I got h of 2 is 6. So now let's evaluate when my input is negative 9 for f. So 8 minus 3 times negative 9. So 8 plus 27. Well, 27 plus 8 is 35. Okay? So f of negative 9 is 35. So now that I've done that work, I have 3 times h of 2 is negative 6 minus my f of negative 9, which is 35. You see how I'm doing that? I'm just piecing it together. And then I I get negative 18 minus 35, and negative 18 minus 35 is negative 53. And that's my final answer, okay? So it's a new concept, but we're building and building. So if you have questions, let me know. Okay, so now it says when f of x is negative 13, find x. So I'm finding x when my output is negative 13. So how would I write that? It says find x when my output is negative 13. So here's what it's saying. It's saying my output is negative 13, and my f function is 8 minus 3x. Do you see that? I'm finding x, and this is my function. So now I solve for x. I do what I do, and I have been doing all year. So I subtract 8. I get negative 21 equals negative 3x. Divide both sides by negative 3, and x equals 7. So 7 would be my answer for 15. So you really have to know vocabulary and what the question is asking. So let's look at let's look at my h. So it's negative 2. So my h of x is, I'm going to do 16. I just want to be able to see it. Is negative 5 half x minus 1. So now the question is asking if h of x equals 39, so if my output is 39, my output's 39, find x. Negative 5 half x minus 1. So now what do? I solve for x. I add 1 to both sides. I get 40 equals negative 5 halves x. How do I get x by itself? Multiplicative inverse. So I multiply both sides by negative 2/5. Negative 2/5, and we should be able to do that in our head. 5 and 40 cancel out to 8. 8 times negative 2 is negative 16. So x equals negative 16. That's my answer there. Okay, I'm running long on this video, but it's really important that you understand. So let's get to, all right. Let's get to where we can see it. 100. Okay, so application. So anthropologists use the length of certain bones of human skeletons to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61.41 plus 2.32x can be used. So this is the equation that's going to be used. And we know what it's asking. It says that x is 40. So what does this 46 mean? Well, x is saying a female with a femur length is going to be x. So 46 stands for the femur length. And what can I get from it? It's going to use to estimate the height of the living person. How cool is that? So all these anthropologists digging up bones, they have found this equation that if you find the femur length, that you can actually quantitatively measure the femur length, we're going to use this a formula, and then it's going to spit out a height for me. So all it's asking, it's saying find the length if you know that the femur was 46. So when we multiply that and add 61.41, we are going to get 168.3, and it stands for centimeters. So 168.3 centimeters is what the height of this female would be if the femur length is 46 centimeters. Okay? All right. Now, look at if we're given a graph. So now, remember, we got to be able to read it given a table. We have to read functions given a graph, given a mapping, given ordered pairs. So if it's asking me, remember, this stands for output. That stands for my y value. So now it's asking me, look at what x is. When x is negative 3, let's look at where here's my x value, here's my y value. When x is negative 3, 1, 2, 3, what is my value of y? Right there. It's positive 2. When x is 0, so we're going to go here on my x, and we're going to say when x is 0, right here, what is my y value? So I go up and I find my graph. It's 1, 2, 3, 4, 5. When x is 1, so where we identify 1 on our graph, what is where's the curve match? Here, on 2. When x is 2, 1, 2, what is my y value? Down here at -2. So input and output, input and output. So I'm locating all these points that intersect the graph, and these are just specific directions. So it's asking me, you know, when x is -3, +2. To me, these are the easy ones to read because you're just reading a graph. It's real easy to identify x and y. Uh-oh. This video is running so long that it shut off. Okay, still going. Sorry. Last one, 19. Okay, so when x is -4, 1, 2, 3, 4, my y value is +2. When x is +2, 1, 2, my y value is -2. When x is 0, y is 0. When x is 5, 1, 2, 3, 4, 5, x is -1. Okay, a lot of information in this video, a lot of it is new information. So if you are stuck on your notes and you don't understand what's going on, please, please, please come see me for tutoring so we can go over this. Good luck.